Welcome to Service Workers, or how to run a man-in-the-middle attack on your own site for fun and profit. We, and by we I mean web developers, have broken the web. We've built the front end around JavaScript, which is a fragile house of cards. It's unreliable and easily broken, as anyone who's ever run into a blank web page or a button that does nothing when clicked can easily attest to. All of this JavaScript has big performance implications as well. Bandwidth has gone way up in the last 5 years. It's actually about 3 times faster on average on both mobile and desktop than it was in 2017. But because websites have gotten bigger as well, and because so much of the front end is rendered in the browser with JavaScript now, the web isn't actually meaningfully faster than it was 5 years ago. And the problem with averages is that some countries have internet that's actually up to 6 times faster than 5 years ago. But many countries continue to struggle with desktop speeds that are slower than the average mobile speed was 5 years ago. Bandwidth is not evenly distributed, and as is often the case, people who live in poverty tend to suffer the most. So what I want to talk to you about today are service workers, a newer-ish tool in our toolkit that we can use to provide more resilience in the things that we build. Service workers can make our sites faster and allow us to build websites and apps that continue to function even when things go wrong. Hi, I'm Ferdinandi. That's my face. You can find me online at gomakethings.com. I'm known on the internet as the vanilla JS guy. I teach people JavaScript and ironically spend a lot of my time telling people to use less of it in the things that we build. I write a free daily newsletter and create courses and run workshops. And you can find more info about all that at gomakethings.com. Here's the agenda for today's talk. We're going to spend a bunch of time talking about what service workers are and how they work, and then we're going to dig into some specific strategies you can use when implementing them. Finally, we'll take a look at some cool things that you can do with them. I always find that looking at specific tangible examples helps make this stick. We are going to look at code, but we only have about 18 minutes left, and you could easily fill an hour-long talk with just code examples, so we're going to stick to some pretty high-level surface examples. So, what is a service worker? Whenever a browser accesses a website or web app that you've built, it reaches out to the network and it gets a bunch of assets back. HTML, CSS, JavaScript, images, fonts. A service worker is a JavaScript file that your website installs into the browser that sits between the browser and the network. And to do that, wherever you would normally load the rest of your JavaScript, you write a little bit of JS. You check to see that the navigator object exists and that it has the service worker property, because older browsers don't support this. And if it does, you can use the register method to register a service worker, which is just a JavaScript file. And then in the background, the browser will download that file asynchronously. And the next time a user visits your website, it will install it and activate it. And once it does, your service worker intercepts all requests that go out to the network and all responses that come back from it. And because a service worker is a JavaScript file, we can do that with a fetch event listener, just using the add event listener method. And we can do things with those requests and responses. What makes service workers really powerful is that they have a built-in storage mechanism. They have a cache, and it can hold a lot of stuff, way more than local storage or cookies can. And you can actually take those responses that come back, save copies of them in your cache, and if something goes wrong with the network, you can load assets from your locally saved cache instead of the network, or cut it out altogether if you want. A service worker is a man-in-the-middle attack on your own website, but like a good one. Now, obviously there's a lot of potential for abuse with something like this, so service workers require browser encryption and SSL certificate to work. There's an exception to this made for locally hosted sites, so if you're just running it on your laptop to test it, you don't need a certificate for that. But as soon as it goes out on the web and you visit it with a URL, you're going to need to install an SSL certificate or the service worker won't work. Let's take a look at some service worker strategies. There are 2 basic approaches that you can use: network first and offline first. With a network first approach, you initially check the network to see if there are any responses. And if you get one back, you pass it through to the browser, probably saving a copy of it in your cache. If for some reason something goes wrong and it can't find that asset, or your site goes offline, you can check the cache, your local storage, to see if you have a saved version of that request. And if you do, you can send that along instead. And here's what the code for that looks like. You're going to use the respond with method on the event request. And for this approach, you actually use a vanilla JavaScript fetch method to take that request and make another call with that request. When you get a response back, you can use the clone method on the response to make a copy of it and save it to your cache. And then you can return the response back to the browser. And if something goes wrong inside your catch event on the fetch method, you can check the cache to see if you have a copy of that request already stored. And if you do, you can send the response associated with it back. It's really, really handy. Network first works best for frequently updated assets. So HTML documents, if you have APIs that you're calling often and you always want to get the freshest data, you probably want to rely on a network first approach for those as well. Offline first works kind of the same way, but it just reverses the order. So when you get a request in, the first thing you do is check your local cache to see if you have a version of that request saved already. And if you do, you use that. If you don't, then you reach out to the network and you save a copy in your cache before sending it back to the browser. And here's what the code for that looks like. Once again, we're using the respond with method to send a response back for that request. But this time we're checking the app cache first to see if there's anything stored there that matches the request. If there is, we send it back. But if not, we use the fetch method again to make a live call to the network for that response, or for that request rather. And when we get it back, we can clone it, save it into our cache, and then return the response. Offline first is best for static assets that don't change as much. So CSS, JavaScript, images, fonts. You can also use service workers to provide fallbacks when things go wrong. And this works for both network first and offline first approaches. With the network first approach, you make a call to the network. If you get nothing back, you check the cache. And if you still find nothing back, you can return a different asset. This could be something that you downloaded when your service worker installed for the first time. You may preemptively cache some fallbacks for when things go wrong. Or you could make a live call to the network in real time. With an offline first approach, you do the same thing, but in reverse. You check your cache, you don't find anything, you check the network, and if you still don't find anything or you can't reach the network, then you send along a fallback instead. And here's what the code for that might look like. When a service worker installs, it actually triggers an install event inside the service worker file itself, so you can listen for that with an event listener. And when that happens, you can open up a new cache and make a request to whatever assets you want to save with the new request constructor. And so in this example here, I'm requesting the offline HTML document that I want to send to people whenever they can't find pages. And then inside my fetch event listener, inside the catch handler, I am going to check to see if that request is cached. And if for some reason it's not, then I'm going to send back the offline HTML document that I have cached instead. Let's take a look at some uses and examples of service workers. This is where I think things really start to stick. So a really low-hanging fruit here, the example we actually just looked at, is showing critical information when a site goes offline. So if someone loses connectivity entirely, you can still give them a usable experience. And this is really particularly useful for things like restaurants, conferences, and hotels. With a restaurant, for example, you might let the user know they're offline and then give them other things that they might need or want from your restaurant. Phone number, an address or directions on how to get there, maybe an abridged menu and a phone number to call to make reservations. For a conference, you might have the schedule for that conference, the venue, and the name of the organizer in case someone needs to get in touch with someone and just can't get the webpage to pull up, or they're having connection issues, which is pretty common in hotels and conference venues where a lot of people are using the Wi-Fi and things kind of break or go down. Extending this a little bit further, you can cache pages in real time as people visit them. And then if for some reason they go offline, you can show them a list of the pages they've visited and make those available to them even though the site is offline. And this is particularly useful for reference sites, news sites, social networks, utility apps. Just because the site is offline doesn't mean people can't still use it and access things that they've already been to. You can use service workers to cache core assets for performance reasons. Things like CSS, JavaScript, images, fonts, any of these really heavy, commonly used files, you can save them locally and then serve them from the network, from the cache rather, instead of going out to the network. This is also really great for people who are on low data plans or live in an area where downloading things takes a really long time. This can dramatically speed up performance. Once you have that asset saved, you can serve it from your cache over and over again, and it returns instantaneously instead of taking a few hundred milliseconds or several seconds, depending on what a person's connection speeds are. And as you may have picked up by now, you can use these different techniques in conjunction. So you don't have to only choose offline first or network first. You can use those different approaches for different types of assets. So for things like CSS and JavaScript, you may go offline first for those, and then you may use network first for your HTML and API requests and have those as a fallback when things go offline. Now, on the more extreme end of things, you can go fully offline. And this is great for things like apps and games, where once you download the initial assets, the HTML, the CSS, and the JavaScript, you have everything you need. You never need to go back out to the network. So think about a utility app like a calculator or a game like a JavaScript-based Pac-Man game. And if you pair this with a manifest.json file, you can turn the simple web app with a service worker into a progressive web app that users can install onto their home screen and then load fully offline without any of the browser Chrome. So it functions like a native app, but it's a web app that works completely offline. Now, my personal favorite use for service workers is replacing single-page apps, which tend to be really fragile and easily broken, with multi-page apps that are more resilient and, in my experience, actually provide a better developer experience. With a single-page app, the whole site or app exists in a single HTML file. JavaScript renders the content, handles URL routing, and so on. Now, the thinking behind this is that because only the content refreshes and you don't have to re-download all of the JavaScript and CSS, each page loads faster. And if you have an API-driven site where you're getting data from an API request and then using that to render your content, you can hold that in memory as the pages change, and you don't have to constantly make new API calls every time the page reloads. But as we've already learned, service workers can give you a lot of those same benefits. And the problem with single-page apps is that they break a bunch of stuff that the browser just gives you for free out of the box, and you need to go recreate it with JavaScript. For example, you need to intercept clicks on links and suppress them. You also want to detect if the user right-clicked on the link or command-clicked and they're trying to open it in a new tab or window, and allow them to do that. A lot of single-page apps break this experience and break user expectations. Once you detect that click, you need to figure out which HTML to show based on the URL path. Then you need to update the URL in the address bar without triggering a page reload, because that would defeat the entire purpose. You need to handle forward and backward button clicks, which again, a lot of single-page apps just kind of forget about. Update the document title, shift focus or scroll position on the document, depending on where someone's supposed to be. Again, a thing a lot of single-page apps break. And then you really want to shift focus back to either the document or more ideally the heading element so that screen reader users get an announcement telling them that the page has changed and they know where they are. This is another thing that a lot of single-page apps forget about and break and make the experience bad for their users rather than better. One of the things people love about single-page apps is that if the internet connection drops, you can still use the app. And page loads feel instantaneous. But when paired with service workers, multi-page apps give you those same benefits, but with more resilience and less developer complexity than a single-page app. You can still render HTML with JavaScript. This approach is aided by static site generators, which let you combine templates and markdown files to pre-render hundreds or thousands of HTML files. Because they require no server rendering, they load fast and they can be cached easily with service workers. And when you pair them with CDNs, you make the experience even faster. Now, when I talk about this, I always get asked about the API piece of it. So you're making a call to an API, and with a single page app, that would just live in the browser memory and you never have to worry about it again. But with a service worker, you still make a call out to the network just like you would the first time you load a single page app. And then you cache that JSON response in your service worker's cache instead of just trying to hold it in memory for the entire session. The caveat here is that you usually want to put an expiration date with it. So you want this to eventually go away, either when the user logs out or when the session ends or after a certain period of time. And then every subsequent request, every page load for that API, you load it from the service worker cache instead of reaching out to the network. And this effectively gives you that same instantaneous response that you would get if you were just holding it in browser memory, but without all of that developer overhead. Everyone who buys one of my courses or workshops or ebooks gets access to a portal where they can download all of their stuff. And it's a multi-page app built this way. The logo, navigation menu, and page heading are all baked, hard-coded into the HTML using a static site generator. The content varies from user to user, and that comes from an API call, which is loaded dynamically with JavaScript. I've recorded a video of me navigating through this portal in real time so you can see how fast the experience is. Most of my students actually think it's a single page app, but it's not. It's a multi-page app, and the pages load seemingly instantly because they're using statically rendered HTML and API data that's being served locally from the cache. So it's instantly available as soon as it's requested. And it results in this really fast experience that was easier for me to build, easier for me to maintain, and is way more resilient than the single page app version of this would be. And I know because I built both versions and compared them to see which one worked better, both from an ergonomic experience for me and a resilience perspective for my users. So if you remember only one thing from this talk, what I hope you take away is that by using service workers instead of the fragile house of cards that we have today, we can build a faster, more resilient web that works better for everyone. I've put together a bunch of resources for you over at gomakethings.com/PWA Night. You'll find the slides from this talk, as well as articles, podcasts, books, and more. Thanks so much. It was really great chatting with you.